All right, so for the review, we'll get through all of this today, and then at the end, if there are any other questions, we'll go from there. And this is taking us back to the beginning. Remember when we did this verbal models? You take a scenario, Colorado, if you didn't know this, roughly a rectangular shape. It's not exactly, but for the sake of this question, we'll say it's a rectangular shape. Anytime that goes on, I usually like, well, let me just sketch a quick rectangle so I have an idea of what it might look like. And it says the length is about 1.3 times its width. All right, so I see 1.3 times its width. So as I think through length, I'm trying to come up with equations, because this is algebra, so that's what we're doing all the time. We're coming up with equations. So if that's the case, then if the length is 1.3 times the width, and then this would be the width, and then I know that the fact that a rectangle, that's a width, and this would be 1.3 W as well. It then says the perimeter, and that's a matter of remembering what does perimeter mean. Perimeter means if you're going to walk the perimeter, you're going to go on the outside edges, going to add up all the sides. So the perimeter is width plus 1.3 width plus 1.3 width for a grand total of 4.6. W is the perimeter, which is 2,070. And then we're going to divide by 4.6. That's a 4. 4.6. 4.6 to get an answer for the width, which is 450. So again, making sure that you're verifying and validating these numbers on your own in your own calculators. Reminder for the exam that you need to have a calculator. Cannot use your phones. I'm not going to have a calculator for you to use. And it has to do all the functions that we're going to do during the review. Obviously, add, subtract, multiply, divide, square roots, and logarithms and exponents. So make sure you bring one to class. If you don't, you are going to be significantly detrimental to your progress. So got to finish that one out. That's the width. So then the length is, it said in the question, 1.3 times that. So then the length would be 505, and you can verify that on your calculator by multiplying it by 1.3. Not a bad idea when you get done just to go quick. All right, just add those up quick and make sure that 450, 450, 505, 505, they all add up to 2070 to make sure you didn't do a quick little calculation mistake. But as it goes along too, just remember the way I grade calculation mistakes. If I see how you set it up, you've got work, I can follow the flow, and you make a slight calculation error, you transpose a number. So like I did here accidentally, that 4.6 was a 4.4 accidentally, and you get wrong numbers technically. Because the process is right, you're doing everything else correctly, but you just transposed a number, you would still get full credit on a question like that. Again, for me, yes, the answer is important. Answers are always important, but process is way more important. So if it's a full correct process you got there, you just made a simple calculator mistake or you wrote something down incorrectly, that is just a fact of life. You're always going to make simple mistakes. That won't count against you as far as I'm concerned. Solving here. So at first I look, and as I'm looking through a lot of the questions that we're going to hit today, when it says solve, I'm looking and I see, this is a linear equation. What do I mean by that? I mean the highest power is 1. So if the highest power is 1, I'm just going to set it up, and at the end I want to have x with something else, behind it. X equals, but in this case it's going to be an inequality. But then, always thinking about this. Order of operations. Got to do what's inside parentheses first. There's nothing there that I can simplify. There's no exponents. There's no roots. There is multiplying. There it is. This is multiplying, so I'm going to have 3/7 x minus 12/7 greater than or equal to x plus 2. And it's at this point that I usually look at this and say, especially for sevenths, not a big fan of fractions. So if I want to eliminate fractions on everything, I'm going to multiply everything by the same denominator. The denominator here is 1, the denominator here is 1, so my common denominator is 7. And when I do that, 7 times 3/7, the 7's reduce, leaving me with 3x, 12, greater than or equal to 7x plus 14. Now it looks a little bit more reasonable and manageable for me. just because, again, without the fractions there, it's a little bit faster and easier, and I'm not left trying to figure out what that is on my calculator. I'm not wasting time going back and forth and punching numbers. For me now, I look at my x's, and instead of moving all my x's to the left side, which is common practice, I'm going to look at this and say, well, there's more on this side. So I'm going to move them to that side because I want my x's to stay positive. Subtract 3x, subtract 3x. And then I'm also going to move my numbers to the other side, so minus 14, minus 14. And since I'm doing the identical thing to both sides, I'm left with on the left, negative 26 greater than or equal to 4x. Divide by 4. And although I wrote it with the x like this, I'll go ahead and just leave it on the right side. X, and that will be negative 13 halves. And if you want to write it this way, with x there and the negative 13 halves on this side, just got to make sure that the inequality, like the pointy end, if you want to call it that, the less than side of it is pointing at the x. It's like this. The reason why I did it this way and had all my x's on the right-hand side instead of moving them to the left is if I move it to the left, subtracting 7x, I would have negative 4x on the left. And then the biggest mistake people would make is at the end, on the left, you'd have negative 4x greater than or equal to, it would have been positive 26. If you divide by negative 4, x, most people forget and they would rewrite the same symbol. I say forget because that would be wrong. When you divide by a negative number or multiply by a negative number, because you're changing the signs, that sign direction also has to change. And that's why I tend to move all my x's to the one side where there's more x's, so I don't have to worry about that. And then there's some questions like this that take us way back to go, wait, was this even part of this class? Very vaguely right at the beginning, but it was, is this a solution, aka solution? Does this make this true? And yes, it's as simple as 3 times, and then the x value is negative 2. That's the 3x. Plus 2 times the 3, and that's the 2y. Negative 6 plus 6, that's 0. 0 equals 0, so yes, it's a solution. In a problem like this, don't forget to actually answer the question. Is it a solution? Showing the work is good, but then you have to actually answer the question. All right. For those of you that are moving on after this class to take stats, there's more emphasis put in this. I would say not more. If this is missing, it's like half of the question, because the work is one part and then actually answering what the question is, because life will be much more about answering the question than just saying, well, I showed my work. You're gonna have to do all the work, have that work to back it up, and then the solution, which is the answer and why you're doing what you're doing. All right, solving systems of equations. In this case, my recommendation, well, I mean, go do whatever you want. If you want to do solve by substitution, you can do that. I like linear combinations when they're set up so that they're x's over the y's. So if I need to start by eliminating one variable. So sometimes linear combinations is called the elimination method. It's the same idea. But I want to eliminate the x's or the y's. Because this is a negative 3y, I'm going to take this first equation and multiply it by positive 3. So that when I line it up, 3x plus 3y equals negative 9. Most common mistake I see is people forget to multiply the 3 by the negative 3. They'll do this and this and then leave it as negative 3. You're multiplying everything by that in order to keep my equation equal. Now I'll add 5x equals 10. X equals 2. But then I got to finish. I'm going to take this 2 plus y equals negative 3. Subtract 2, y equals negative 5. And then my solution is 2 comma negative 5, because a system of equations, when we solve them, what we're finding is this is the intersection point. That is where those two lines intersect if we were to graph it. Graphing technique, not a valuable technique anymore. You did that a long time ago when you did algebra, maybe even pre-algebra, to see this is what's going on, this is the visual representation, which is good to understand that because this is the answer. But it can be inaccurate unless you are drawing just the most precise graphs in the world, which you probably aren't, especially on an exam when you're trying to hurry through things and get things done. So, could you use substitution method? Absolutely. I find this one a little bit faster. Simplifying. This one was harder to do. Let's see if it'll let me erase this little piece here. No, it won't let me. This negative 2 should be on the entire parenthesis set for big parenthesis, and the whole thing is to the negative 2 power for you to get a better sense of what's going on there. So do what's inside the parentheses first. I have 5x to the negative 3rd over x squared using my principles here. So it's going to be 5. I have exponents, x to the negative 3 minus 2, because when I'm dividing fractions of the same bases, I am subtracting exponents. So that's going to be 5x to the negative 5th, which is 5 over x to the 5th. Mistakes I see common. People think that this negative 5 is somehow related to this 5, and it's not. That negative 3 is only on the x. For that negative 3 to also be on the 5, this would have to have its own set of internal parentheses, which it does not. So I've got this, which is 5 over x to the 5th. Originally, question is, that whole thing is to the negative 2 power. Well, the negative means I'm going to flip it, and now it's squared. And then powers raised to powers. My power on my 5 is 1. Or you can just think, and sometimes it's easier when it's a small number like this, squared means times itself, x to the 5th over 5. So I'll have x to the 10th over 25. All right, then we get to solving, dealing with bigger fractions, simplifying, solving, that kind of thing. Again, my recommendation, you can do it the way you want to do it, but I like to either get rid of my fractions or at least find my common denominator. And because I've done this a million times, you look at this and see right away that, oh, wait, this is factorable as x plus 3 and x minus 3. Because it's a difference of squares, which we've done not 1,000 times, but I will be dramatic and say we've done this 1,000 times. So in order to have common denominators, I need to get this to also include an x plus 3. So this 1 over x minus 3 is going to be multiplied by 1. And the 1 I'm going to multiply it by is x plus 3 over x plus 3 times 1 over x minus 3. And now this is where some people get confused and say, wait, well, if I do it to one side, don't I have to do it to the other side? Well, in this case, I'm not changing this. I'm not like multiplying the whole thing by 2 or multiplying it by something else. I'm multiplying it by 1. And since I'm multiplying it by 1, I'm not changing its value at all. So I'm not multiplying this by everything like I did on that previous problem. So then I have plus here, and then in the denominator here, I've got the 2 over x plus 3. So this will be multiplied by 1, and the fancy one is x minus 3 over x minus 3. That's a 3 minus x minus 3. And then on the right side, I have 1 over x plus 3 times x minus 3. So now, because they all have the exact same denominator, at that point, since the denominators are the same, I can essentially exclude the denominator. Because if they're equal and they all have the same denominator, that means the numerators must be true. So my first fraction is x plus 3 times 1, which will be x plus 3. And then it's plus, which is nice. What you'll see from me often is this is oftentimes a minus, because I want to see if you're paying attention to how the minuses might distribute. But now the second part is plus x minus 3 times 2, which I'm going to go ahead and distribute that in. So that'll be 2x minus 6. And I have my equal sign, and it equals 1. And now I'm back to just a linear equation, like where we started from. So I have on the left-hand side 3x minus 3 equals 1, because x plus 2x is 3x. 3 minus 6 is negative 3. I'm going to add 3. 3x equals 4. X equals 4/3, assuming that I didn't add or subtract something incorrectly. But procedurally, this is how you go about doing it. Find the common denominator. Once you have it set up with the common denominator, then I can just set the numerators equal to each other. Factor. When I have this as a factoring question, it would be fantastic if this first number were a 1. It's not going to be that way very often. So then what we're probably going to have to do is factor by grouping, which means I'm doing AC, which is 28 times negative 10, or negative 280. And you go, oh boy, what am I going to do? Well, I need the difference to be negative 27. And the quick place to start is, well, can we be lucky enough that negative 10, actually it would be positive 10, and the reason why I know it's positive 10 and negative 28 is because this middle number has to be negative, so when I'm doing this, the bigger number has to be the negative number. That would be then adding to a negative. But the difference here is negative 18. All right, so that's negative 18. That doesn't quite get me there. So I need two numbers that are a little bit further apart. So I'm trying to think of other numbers that might go into it, and then this is where it's going to honestly, negative 280 isn't a number on your 12 by 12 multiplication chart. So you're going to just have to think a little bit bigger than that. It would also have been nice if all of these could have been factored out, but this is only divisible, this is divisible by 3, but 10 is not. They don't have a greatest common factor. But pick a number like 8. Meant that to be green. 8. And I think 8 goes in there. Anybody going to check me on this? Maybe 37 times? 280 divided by 8. 35 times. Oh, 35. And then one of them has to be negative, so that 35 is negative because they have to add to a negative. And negative 35 and 8 is negative 27. So this is my pair of numbers. So that middle value, 28x squared, will be split into plus 8x and minus 35x. Now, it doesn't have to be that way. I could do it plus 30. I could do it this way. So it's not plus, though. It would be minus because it's a negative 35. Negative 35x plus 8x minus 10. It can be either way. And then I look at my pairs, because now I've got grouping. What number goes into 28 and 35? 7. What goes into x squared and x? X. And then I'm left with 4x. Again, because if I were to remultiply those two, it gives me 28x squared. Minus 5 plus, divides into 8 and 10. That'd be 2. Leaves me with 4x minus 5, which it should, because the purpose of factor by grouping is that whatever's in that parentheses is the same. So that 4x minus 5 gets factored out, leaving me with a 7x plus 2. And then I'm done because this did not say solve. If it would have said solve, this would have been set equal to 0. This would have been equal 0. And then I would have had to take 7x plus 2, set that equal to 0. 4x minus 5, set that equal to 0 and solve each of them, because if two numbers multiply to 0, one of them has to be 0. So what would make this 0? It'd be 5/4. What would make this 0? Negative 2/7. But you'd find that out by solving those. And only because that last slide included a bunch of these, anytime you see it, you think, oh, yes, I better know how to do this really quickly because it is the difference of squares. So this would be x plus 2, x minus 2. This one, the only thing that's different is the second one is a y squared instead of a 2 squared. Up here it was a 2 squared. That's a 2 squared. This is a y squared. It's x plus y, x minus y. And I look at this one like, all right. I see numbers that are squared. So it's going to be 2x and 2x because that'll be 4x squared. 5y and 5y. And again, they're the same exact thing, plus and minus. Here, it's not exactly there yet, but GCF, always thinking, is there a GCF? The first three there was not. This one there is. 2x comes out of each of them, leaving me with 4x squared minus 25. Oh, there it is again. So this would be 2x. That's 2x and 2x because it's 4x squared. It's 5 and 5 because it's negative 25, plus and minus. That should be something that I've done, I've shown, you've seen many, many times. Needs to become instinctual. When it's already factored, it's kind of nice because I have three things, 1, 2, 3, that when multiplied, because it's multiplying, they have to be 0. So either this thing is 0, this is 0, or this thing is 0. All right, so 5 times what number is 0? Or I divide both sides by 5, either way you think about it. If I divide by 5, x equals 0. Remembering 0 divided by a number is 0, but we can never ever have 0 in the denominator. Those are my impossible values. Here I'm going to add 4, x equals 4. Here I'm going to add 3, then divide by 8. X equals 0, or x equals 4, or x equals 3/8. It can be any one of those numbers. Because if I put any one of those numbers back into the original equation, it doesn't matter what it is in the other ones. Like if I put this 3/8 here, it doesn't matter. 3/8 minus 4, yes, it's a value. 5 times 3/8, yep, that's a value. But this is 0. Number times 0 is 0. Because now we're going to get to this, and then we got to solve. So to solve, we first look for greatest common factor. Is there one? Everybody shake your head and say no. That was really good. Not a single person said no. So then, AC, which is 2 times negative 35, which is negative 70. I need two numbers that multiply to negative 70. We can obviously start with 2 and 35. And since the middle number is positive, that means the bigger number here is positive, so it would be like negative 2 and 35. But that difference is not 3. 10 and 7 is 70. The bigger number needs to be positive, so the other one is negative. And there the difference is 3, so that's my split up. 2x squared plus 10x minus 7x minus 35 equals 0. They're grouped and factored. 2x comes out of both of those, leaving me x plus 5. Whenever this number is negative, when I do the grouping, if that first number is negative, I need to factor it out as a negative. So negative comes out, and then 7 and 35 are both divisible by 7, leaving me with x plus 5. Because a negative, when I divide a negative out, now is a positive. And luckily, I did it right because I got the same value. That's what happens with factor by grouping. So x plus 5, and I'm left with over here 2x minus 7. Remember, it doesn't matter which order you put the parentheses set, if it's x plus 5 and then 2x minus 7. It's the same thing because multiplication, going back in the day, we call it commutative. It can be done in either order. It commutes around. And then set them equal to 0. This here will be x equals negative 5. This one would be x equals 7/2. I'm not going to show the steps on that, but you can do that. We've done it on the previous slides as well. Setting up 2x minus 7 equals 0. Solve for x. X is 7/2. So x is 7/2 or x is negative 5. Not that it's part of this question, but what does that mean? It would mean that if I were to graph this parabola at negative 5 and at 7/2, my parabola will cross the x-axis. And because it's a positive 2, that means my parabola is positive, so it opens up. It's going to be down here somewhere like that. That's what that parabola would look like. So that's what's going on. Just like early on, we talked about when two lines intersect. What are we talking about? Well, that's the solution. Find the solution to two equations. It's an ordered pair. This is where does my quadratic equal 0? That is, where will the y coordinate be 0? Because this is negative 5, comma, 0. And if this were my original equation, it would have been y equals 2x squared plus 3x minus 35. And I'd see that it intersects the axis at negative 5 and 7/2. So what we're doing algebraically does connect with something going on geometrically. A little bit more complicated when we get to these rational expressions. So the rational expression here is I have a fraction in the numerator, I got a fraction in the denominator. If I can make them both singular fractions, then I can do, well, we'll do that. In the numerator, it's already simplified into a single fraction of x plus 2 over x. So we're going to just leave it like that for a second. I'm going to take this over here, and I'm going to see if I can simplify this into a single fraction. Right now, they do not have the same denominator. So I need to do something to that first. So this one here, the denominator is 1. I need the same denominator to be x, which means I need to multiply this by 1. And it's going to be x over x. When I do that, this then becomes x squared over x minus 4 over x. Now I've got common denominators. Now I can add, subtract. So then this will equal x squared minus 4 over x, which I can then take back up here to be x squared minus 4 over x. When I have fractions divided by fractions, that means I multiply by the reciprocal. Division is multiplying by the reciprocal. So I took that denominator fraction, flipped it, and now it becomes multiplying. Multiplying and dividing, remember, inverse operations, so it's the same thing as back, you're like, oh, divide by 2, that's the same as multiplying by half. It's the same thing going on here. So now I'm looking to see, are there things I can reduce? Well, I'm going to rewrite this as a thing. Let's see. Let's write this as x plus 2 times x over x times x squared minus 4. I see that the x's reduce because I'm only multiplying and dividing, but then I've got this x squared minus 4 in the denominator. And if I give a dramatic enough pause, you'll go, oh wait. It can factor because it's a difference of squares, because it's going to show up a lot. In the numerator, I have x plus 2. In the denominator, x plus 2 times x minus 2. We got rid of the x's because they reduced. So do the x plus 2's. It reduces to 1 over x minus 2. And then that would be it. That's as far as you could go for simplifying that rational expression. So now we're going to divide. Either long division or synthetic division. Synthetic division's faster, so I'm going to show synthetic division. Synthetic division, I start with writing down all the coefficients of the numerator and making sure, first of all, that I have there's all the terms here. And what do I mean by that? It's cubed, squared, 1, and then none. If one of these were missing, if this were just 2x cubed minus x squared minus 1, and this term wasn't there, I would have to include it in my list. But let me just do this one. 2, -1, -8, -1. So those are the coefficients. And then the number over here is not -2. So if I were to divide this using long division, I would have x minus 2 out in front with a long division sign. When I do it with synthetic division, I'm doing it and basically saying, well, what makes this 0? And that's the number that goes here. All right. This would be called a factor if it divides to 0. This is called a root. But either way, root or 0. There we go. Synthetic division, the process is, after I get it set up, is I bring down the first term, 2, and then it'll be 2 times 2, and I put that right there in the next spot. And that's 4. And then I add. The reason why I like synthetic division is adding oftentimes results in fewer mistakes than subtracting. -1 plus 4 is 3. And then I do it again. 2 times 3, and that goes here, and that's 6. And then I add, and that's -2. And then I go 2 times -2, and that goes here. That's -4, and then I add -5. And then I'm done. -5 is a remainder, which means that this is technically not a factor. If this were a factor, my remainder would be 0. It's not a factor, but either way, when I'm done, now I'm going to rewrite what I had. So when I divided by x minus 2, it's like that, x minus 2. It's like factoring it out. And it left me with 2x squared. Whatever the highest power is, I'm 1 less now. And the next one is plus 3, and that's going to be an x. And then minus 2. And then what do I do with that remainder? Well, it's going to be minus 5 over x minus 2 because that's what I was dividing by. And if we'd go back and talk about what you used to do when you did long division by hand and you ended up with a remainder and then you wrote the remainder as the number over what you divided by, it's the same process. And that would be using synthetic division to divide this out. Equation was 2, 1, 8, 1, right? Yeah. Yes. Now, over here I had negative. If I had to do that by long division, let's see, the 1. So it was 2, 1, 8, 1. So 2x cubed minus 8x, or minus 1x squared, minus 8x minus 1. I think they're all minuses. So if I were to do it longhand, so divided by x minus 2, I would start by saying, all right, x to 2x cubed. What do I multiply x by to get 2x cubed? And the answer is, well, I got to multiply it by 2. And I have to multiply it by x squared. And there's a reason I put it above this one, because really when you're dividing, if x could go into this, like if both of these could go into that, which it can't, I would put it above here. But it goes here because x squared times x is x cubed, and this is the x squared column. So then I'll have 2x squared times x. And again, you're looking for identical. So 2x squared times x is 2x cubed. And then 2x squared times negative 2 is negative 4x squared. And then you have to remember when doing when doing regular division, we subtract. Synthetic division, we add. So we say 2x cubed minus 2x cubed is 0, and that's what I'm going for. It should be. If it's not, I did something wrong. Negative x squared minus a negative 4x squared. So you're like, wait, this is getting complicated now because we've got all these negatives going on. This is why I like synthetic. But negative 1 minus a negative 4, minus a negative is plus a positive. So that'll be positive 3x squared. Then I bring down the next one, which is negative 8x. And then I say, okay, what do I multiply x by to get 3x squared? Well, I got to multiply it by 3 and a positive 3. Need to multiply it by an x, so I get the x times the x for the x squared. So now if I have 3x times x, that will be 3x squared. Yay. And then I go 3x times the negative 2, which is negative 6x. Make my line. And then I am subtracting. Do I make it an obscenely large subtraction sign? Yes. So I can keep track that that's what's going on. 3x squared minus 3x squared is 0, which it should be if I'm doing my problem right. Negative 8 minus a negative 6 minus a negative is plus a positive. So negative 8 plus 6 is 2x. Bring down the 1. X into 2x, this has to be plus 2. Multiply 2 times the x over here. 2 times x, 2x. 2 times negative 2, negative 4. Subtract. And I'll get negative 3, 5. So I don't know what I did different. This 2. Oh, I know what I did. This right here. Negative 8 minus a negative 6 is plus a positive. This should have been negative 2. That means this number up here shouldn't be positive 2. It should be negative 2 to match. So when I multiply it, this is negative 2. This is a positive 4. So now this adds to 0. And now I have negative 1 minus 4. That's negative 5. So maybe I just demonstrated to you why I also don't like doing it long division this way is I lose track of my subtractions and my negatives. It's so much easier for me if I'm just doing adding. My remainder is negative 5. So then this would be minus 5 over x minus 2. And then that should be the same answer I had on the previous page. All right, solving here. When I have square roots, to do this, our habit has always been move all my x's to one side, all my numbers to the other. But when there's a square root involved, I need to take a break from that for just a moment. And I need to move and have only the square roots on one side. So in this case, what I'm actually going to do is I'm going to add the square root of x plus 1 to both sides of this equation because it's already equal to 0. On the left, I'll have x minus 5 equals the square root of x plus 1. Now I want to get rid of the square root because that's what I really want to do. I want to isolate the square root onto one side of the equation, and then I want to get rid of the square root. on the right-hand side, everything is being square rooted. So the inverse of square rooting is squaring, and whatever I do to one side, I must do to the other side. Squaring means times itself. On the left, I'll have x minus 5 times x minus 5. If your instinct was to be like, oh, this goes into each of them and is x squared minus 25, that would be wrong. So don't do that. Squaring, slow yourself down in your thinking, and remember, squaring means times itself. On the right-hand side, the square and the square root are inverse operations. And again, because the whole thing was being square rooted, when I square the whole thing, they, for lack of a better phrase, cancel each other out, even though that's not really what's happening. But I have x plus 1 on the right. On the left, I'll have x squared minus 10x plus 25. I did FOIL and I simplified. This equals x plus 1. Now I have a quadratic, and the process for solving quadratics is move everything over, so I have it set equal to 0. Subtract x minus 11x. Subtract 1 plus 24 equals 0. Now, can I factor that? This will be x, this will be x. I need two numbers that multiply, right? Because this is 1, so it's a little bit easier now. Two numbers that multiply to positive 24 add to negative 11. Well, the add to negative 11 multiply to positive, that means that they're both the same sign, which means they both have to be negative. Negative times negative will be a positive. And let's see, 6 and 4 multiply to 24, but that's a difference of 10. 8 and 3, they multiply to 24, and they add to 11. Yay. There's my pair. And then lastly, I'm solving x equals 8 or x equals 3 because I'm looking to see what makes this 0, what makes that 0. 8, 3. Ta-da. All right. I have two problems related to this. First, it's this. I have f and I have g, and I need to find this. This means f of g of x. That FOG, fog, f of g of x. Means I'm going to take in the f of x function, because that's my outer one, I'm going to replace the x with g of x. So this x right here is going to be replaced with this whole thing is going to go right in there. Composite functions. So f of g of x would be equal to 3 times x plus 5 over 3 minus 5. And then I'll simplify. Well, this is 3 over 1. So when I bring it in, 3 times x plus 5 over 3 minus 5. Look at that. 3 and 3. Reduce. So it equals x plus 5 minus 5, which is just x. All right. And then the second part of this question says, find the inverse function of f. Inverse function notation is this, f to the negative 1 of x. That's what we're looking for. And the process is I take the f of x function. Let's kind of block this off. The f of x function is, I'm going to rewrite it as y. Y equals 3x minus 5. To find the inverse, I flip-flop the x and the y. That's the procedure for finding the inverse. And then solve for y. Going to add 5 to both sides. X plus 5 equals 3y. Divide by 3. 3's reduce. Y equals x plus 5 over 3. Once I get it like that, then that y is my inverse function. F of inverse of x is equal to x plus 5 over 3, which at the beginning part of this equation was also what the g of x function was. All right? But that's how you find the inverse. Moving right along, logarithms. For most of logarithms, it's being comfortable in being able to flip-flop back and forth between logarithmic and exponential form. And when we taught this, it was remembering that if I have log base a of b equals c, or something like that, where anything can be a, b, and c, numbers, letters, you name it, the format of logarithms is this is the base, which means as an exponent, a is the base, and it's raised to a power, and the power is what the logarithm equals. Log of something, whatever it equals, this is the exponent. So it's a to the c power equals b. And sometimes I've done this. Start with a, go to c, then to b. So it's a to the c equals b. A logarithm is the same as an exponent. They are just written two different ways. They are not two different things. They are the same thing. We just write them a different way. And the reason why we write them a different way is sometimes the exponent is what I want to find. So if that's the case, I can rewrite it as a logarithm and then solve it to find out what my variable is. So if my exponent's my variable, I can redo it as a logarithm to find that answer. So in this case, I just follow the same format, and I go, oh, well, this will be 5, because that's the base, to the 3 power equals x. In other words, x equals then 125, because 5 cubed is 5 times 5 times 5. Other way around, if I have something that is in exponential form, and I'm asked to convert it into logarithmic form, I start with the exponent. This is what it's going to equal, because the exponent, again, log base a of b equals c. The c is the exponent, so 3x minus 2 equals, the base is a, my base here is 10, because that's the base of the base raised to a power, the base is 10. So I'm going to have log base 10 of, and then that's the number that was here, is the equals here. So again, this is just a matter of, can I take this, can I plug it in, can I change it into a different format? Now, your calculator is log base 10. So you can either write it as log base 10 or log base nothing. It's the same thing. When there's nothing written for a log, just as log and there's no base, it is common knowledge in mathematics that that's 10. And now if you'd actually do this in your calculator, which I encourage you to do right now, is find the log of 0.01, and you'll find out it is -2. And the reason why is 10 to what power is 0.01? Well, 0.01 is 1/100th, which is 1 over 10 squared, and 1 over 10 squared is 10 to the -2. That's why log of 0.01, the log of 0.01 is -2. And you should get that when you plug it in your calculators. This is more a matter of, am I plugging things into my calculator the right way? That equals 3x minus 2. Wait, now we have an algebra equation that I can solve. Add 2. 3x equals 0. X equals 0. And if I were to go back and put this in, 10 to the 3 times 0 minus 2, which is 10 to the 0 minus 2, which is -2. Negative exponents mean I flip it, so that's 1 over 10 squared, which is 1 over 100, which is 0.01. Check. Just so you're seeing, that's where all this is coming from, and getting comfortable, at least in part, with transferring them, converting them from exponential to logarithmic, and logarithmic to exponential. Then with logarithms, when I have a larger problem here and I have logarithms going on that are multiple logarithms, as long as they are same bases, I can use the properties of logarithms. And we talked about 3 in class. When I have the same base logarithms and add, when I have the same base logarithms and subtract, and then when I have same base logarithms and exponents, then there's that special rule there. But for this one, I have same base logarithms and I'm adding. And as long as all my logs are on the same side, which is what I want, they can combine log base 2. And when they're adding, that's multiplying. So that's x times x minus 1. This will equal 1. Now that I have it as a single logarithm, I can change it into an exponent. My 2 is my base. 2 to the 1 power equals x times x plus 1. So 2 equals x squared plus x. Oh, now it's starting to look like a quadratic. Subtract 2 from both sides. Plus x. And then minus 2, because I subtracted 2 from both sides. Can that factor? 2 numbers that multiply to negative 2 and add to positive 1. Positive 2 and negative 1. Because 2 times negative 1 is negative 2. 2 plus negative 1 is positive 1. There it factors. And it equals 0, which means x will either be 1, because that would make this 0, or x would be negative 2, because that would make this 0. At some point you're realizing, so do all of these problems come back to a quadratic that I can factor? In many cases, yes. Why? Because it's a big deal. All right, and then this was from, I think just the last time we got gathered for class. When I have 10 people that come into a room, how many ways can they finish first through fifth place in a game? So finishing first through fifth means order matters, which means this is a permutation. And then the permutation, that's a C. Permutation formula is n factorial over n minus r factorial. So in this case, that would be n, 10 people, permutation r, I want them to be 5 place finishes, first, second, third, fourth, fifth. If it were first through third place, then this number here is a 3. Basically, I'm saying I've got 10 people, I want to pick them in order, and I want to have the 5 of them in order. So then this would be equal to 10 factorial divided by 10 minus 5 factorial. And factorial means 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. I apologize that I'm covering up my own n there. In the denominator, 10 minus 5, well, that's 5. So 5 factorial is 5 times 4 times 3 times 2 times 1. And then 1 over 1 reduces, 2 over 2 reduces, 3 over 3 reduces, 4 over 4 reduces, 5 over 5 reduces. I'm left with, just to there, 10 times 9 times 8 times 7 times 6, which is going to be a big number. And that would be how many different ways 10 people can be, let's see, 10, 5, 30,240. There are a lot of ways for 10 people in a room to come in first through fifth place. That's a lot of reading. The Mach number is a measurement of speed, named after a man who suggested it, Ernest Mach. The speed of an aircraft varies directly. Oh boy, that sure sounds like math, doesn't it? Direct relationship, that's this. Where K is the constant of variation, which good idea to just kind of remember in the back of your head. If it's an inverse relationship, it's going to be that constant of variability over X. All right, because direct variation means as one goes up, the other goes up. So it's a direct variation as its Mach number. The Concorde was a commercial jet that flew faster than the speed of sound with a maximum speed of 15. Come on. 1502.2. And it had a Mach number of, so constant of variation times 2.03. Because it tells me they vary directly. Speed and Mach vary directly. So if the speed is 1502.2 miles per hour, its Mach was 2.03. So then there's a K, constant of variation, in there. And I can find that by dividing 1502.2 divided by 2.03. My K is 740. So my equation is, and if I want to make it Y, I can do that, or I can say speed equals 740 m for Mach number. Now it actually, can tie into what's going on up there instead of always just being Y's and X's. Now the SR-71 Blackbird, which for the record is my favorite airplane, is a retired military plane. And did you know, little known fact, on the date it was retired, they flew it to from the West Coast to the East Coast. And on its day of retirement, it broke the record for how fast it could fly from there to there. And at that point, it was almost 30 years old. That's how advanced it was when it was first created. Fun fact. I've met a couple pilots, and they used to be based out of Beale Air Force Base down here in outside of Sacramento. But anyways, it traveled over 2,200 miles per hour. What is its Mach number? All right, now I know the miles per hour. I know its speed. What is that in Mach? We can just put it into that equation. 2,200 divided by 740. So its Mach speed was 2.97. Or in essence, Mach is how many times the speed of sound. So it went just under 3 times the speed of sound. It also has a, I think, still classified ceiling for how high it can fly. It basically gets into suborbit. And it was a spy plane. And then, number of students who show up at class at 8 a.m., oh, look at that, decreases by 8% each week. So then it's remembering this is a exponential function, which was in the format of this, amount equals principal times 1 plus r to the n. My rate is it decreases by 8%. So that rate is negative 0.08. So remembering that when we're doing percent how things are reducing, when we're talking exponential functions, if a rate decreases, that means it's going down. Or in essence, 1 plus r, or 1 minus 0.08, is 0.92. So 92% of the students show up each week, and each week thereafter. How many people show up after 13 weeks? 13 weeks. What did I start with? 285 students. And that will be then the amount that we have. This is not based on real data, although it probably could be. 285 times 0.92, and the 0.92 is raised to the 13th power. So that would be 96.4, but you can't have 0.4 of a student. So 96 or 97 students are showing up to their 8 a.m. class after 13 weeks, which is not too far off from what I saw going on in this classroom. Thank you for all coming on this last day of class. Definitely not the 34 of you that we started the semester with. Yeah, you're all looking around the room going, ooh, yeah, no. And definitely, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We are 50% of those who started out the semester and who are still enrolled in this class. So if you're listening to this now and you didn't come to class, I know you are.